Hello students. Last week we already started with this media access control chapter under the fourth module. Today we'll see the continuation of this. See, we have already discussed random access protocols. One of the random access protocols, that is Aloha. Under that we discussed about pure Aloha and slotted Aloha already. In this video lecturing, we will start with the second type of random access protocol, that is CSMA, that is carrier sense multiple access protocol. We'll see what is this CSMA first. Okay, carrier sense multiple access protocol. Now from the earlier discussion of this pure Aloha and slotted Aloha, there the number of collisions was more, right? So now our aim is to reduce the collision. Okay, this CSMA uses the principle sense before transmit, that is check the state of the medium first and then send the data. That is, you're checking if the channel is idle or if it is free, or you can say there are no carriers in the channel, then the channel is idle. In that case, you have to, the station can transmit. That is the concept used here. Okay, now this CSMA, that is the carrier sense multiple access protocol, can reduce the possibility of collision, but it cannot eliminate it completely. Okay, the reason for it is shown in this figure, which shows the space and time model for a collision in CSMA. Okay, now see to this figure here. You have four stations: station A, station B, station C, and station D. Now we will see the transmission between station B and station C. Okay, now at time T1, what the B station will do is, it will check if the station is, that is the channel is idle or not, and it finds that the channel is idle. So what it will do, it will start sending its frame, that is the bits. It will start sending the bits in the frame. Okay, at a time T1 here. Now at a time T2, what happens is, this frame bit which is sent by B has not yet reached here. Okay, that is due to the propagation delay. It is not, it is on the way and not yet reached C here. Okay, now when C checks whether the channel is idle or not, it will see that there is no carrier and it is free. This channel is free. This thinks that this channel is free, and at this point of time, that is at T2, it will start transmitting. Okay, now at T2 it will start transmitting, and see here at this point what happens is, both B and C will collide here. Okay, collision will take place. Now when this C will understand that it has undergone collision is when this signal, that is from the B, when it reaches a C, it will understand that a collision has undergone here. Okay, at the same time, when the signal from C reaches at this point, okay, it will understand that, okay, there is collision. This collision has, this is the place where collision happens. Next we will see the vulnerable time in CSM. Here you have 4 stations, same 4 stations is shown here. Now at T1 A will sense the channel. At this point B senses the channel, and at this point this signal from T1 A reaches C. This is all propagation delay. Okay. Now at this point D senses here, that is because of the delay D senses this particular data sent by A at this point. That is this difference, that is this the time for A to reach D, that is called, that is the propagation time. This is called the vulnerable time. Okay, vulnerable time means in this vulnerable time the possibility for collision is more. Understood? If at all collision happens, the other channels will not get to know it. Now, there are 3 types of methods, that is persistence methods, to check the channel. Okay, what should a station do if the channel is busy? Or what should a station do if the channel is idle? What has to be done? Okay, we will see to this 3 methods of how to solve this problem. That is when you when you see an idle channel, what to do, and when station sees a busy channel, what to do. Okay, there are 3 procedures. That is one persistent method, non-persistent method, and p-persistent method. Okay, this figure shows the one persistent method. In this case, what happens is, see, a station, what it will do is, it will continuously sense the channel. Okay, it will go on sensing the channel, and it sees that it is busy. Until this channel becomes idle, till then the station will go on sensing continuously, and when it sees when it sees that the channel has become idle, thus it will transmit its frame here. Understood? That is called one persistent procedure. Okay, now here is the data flow for one persistent. See here, it is checking whether the channel is free or not. Okay, if it is free, that is idle, then station can transmit its data. If not, that is if the channel is busy, then again it will go on sensing whether the channel is free, idle or not, whether the channel is free or not. Understood? It will go on sensing again and again until this channel becomes idle. Once if it is idle, it will send the frame there. Okay, next we will see the second procedure, that is non-persistent. Okay, in this non-persistent method, what happens is, see, the station will first sense the channel. Okay, once if it knows that the channel is busy, what it will do is, it will wait for a random amount of time, and then it will sense again. Again, if it is busy, again it will wait for another random amount of time, and then it will sense the channel again. And if it is idle here, that is the channel does not have any carriers, and if it is free, then it will transmit at this point of time. Okay, now I told you it waits for random amount of time. That's why the difference between these two is less than the difference between these two. Understood? The time slot, wait time, here the wait time is more, and here the wait time is less than. Okay. The flow diagram for this non-persistent method procedure. Say, at first it will sense the channel and see, the station will see whether the channel is busy or idle. If it is idle, then this station can transmit its frame. Else what it will do, it will wait. If it is busy, the channel is busy, then it will wait randomly. This is what it is. Okay, it is waiting randomly at for a time period, and then again it will sense the this one. Again it will sense the channel. And in this at this point of time, if it is idle, then it will send or transmit the frame. Okay. Next is the P persistent, that is based on the probability. In this case, what happens is initially this station will continuously sense the channel to check if it is busy or idle. If it finds that the channel is busy, then at this point of time, when the channel becomes idle, what it will do is it will check whether the random time is less than the propagation time, and if it is less, then it will wait for a time slot period, and again if it is busy, then it acts as though a collision has occurred and uses the back off procedure. Otherwise what it will do, it will go to step 1, that is it will transmit the frame. Okay, here it is wait a back off time, that is going back, and then back off time is nothing but TV, that is how much time for propagation into the random period, isn't it? And then again it will sense the channel if it is busy. Okay, it will sense the channel again. If it will check the random period is less than the propagation time, then it will wait for a time slot, and then it will transmit the frame. Okay, the flow diagram for the same is given here. See, it first it checks if the channel is busy or not. This is sensing continuously. Okay, if it is busy or not, and if it is busy, then it will go on sensing again and again until it finds a idle channel. Next, once if the channel becomes idle, what happens? It will generate a random number, number that r is equal to 0 to 1. Okay. Once if it generates a random number, it will check if the random number is less than or equal to the propagation time probability, the probability generated by the frame. Okay, initially the frame will generate a probability. This probability is checked here with the random time. Okay, if it is less than, it will, if it is true, then what it will do, station can transmit. Else if it is false, then it has to wait a slot, that is the random time. Okay, wait a slot, and then again it is checking whether the channel is busy or not. If it is busy, then use the back off process as the collision has occurred. Okay, if not, what happens, it will go back to the step 1 to generate the random number again. Next is collision of the first bit in CSMA CD, the third random access protocol. The first random access protocol is your Aloha. Second one is CSMA, just CSMA, multiple access, that is carrier sense multiple access. Now the third random access protocol is carrier sense multiple access with collision detection. This, okay. In this CSMA CD, that is carrier sense multiple access with collision detection, here a station monitors the medium after it sends a frame to see if the transmission was successful. Okay. If there is a collision, then the frame is resent. It will send the frame again. Okay. To understand better, let's see this diagram here. This diagram shows where A and C collides. Okay, how the collision occurs, we'll see. Okay, now at the time T1 here, okay, at the time T1, station A, it will execute any of the persistent methods. That is, just now we discussed one persistent, next non-persistent and p persistent, right? The station will execute any of this procedure of this three, any one it will execute, and then it will to find out the channel is free or not. Okay, so after once if it finds that the channel is free, what it will do, it will start sending the bits of its frame. See this one, it will start sending the bits of its frame. Okay, now at time t2, see here, time t2, what happens is the station C, that this station here, the station has not yet received this bit sent by station A. So this C, what the station, what it will do is, it will execute one of the three persistence procedure, like anyone, that is one persistent, p persistent or non-persistent procedure. Any one of that it will execute and sees that this at this point of time t2, the channel is idle. It will see that the channel is idle because the carrier has not reached C yet, isn't it? That's why it thinks that the channel is idle here, and then it will propagate its bit. That will, it will start sending the bits of its frame. See this pink line, this shows the bits. It is transmitting the propagating the bits of a frame, both to the right as well as left. Okay, now at some time after this t2, what happens is this first bit sent by the station C and the first bit sent by the station A will collide each other. Here the collision occurs. Okay, now next what happens is the station C will detect the collision at a time t3. Here at a time t3, the C's collision detection and abortion, the station C will detect the collision, and what it will do is it will abort the frame, whatever it has sent. Okay, it will cancel it and it will send a signal to the nearby station, say D, B and all. Okay, saying that there is a collision, a signal. Okay, next here at time t4, when C's first bit reaches A will come to know that there is a collision and it will drop its frame also, or a message, whatever message was sent, it will drop it. Okay, now here we can see that A transmits for a time of t4 minus t1 and C transmits for a time duration of t3 minus t2, isn't it? Now see to this next diagram here, which shows the collision and abortion in CSMA CD. Okay, now this is the same diagram as the last one. Okay, now this CSMA CD to work, we need to restrict the frame size. Okay, before that, let's see in this diagram, same thing is given, A and C, collision of A and C here. That is, this is the point of collision where A collides with the C, and this transmission time of C is T3 minus T2 from here to here. This is the point where C detects the collision and it will abort its message. Next here at a time t4, This is the transmission time T4 minus T1, and at this point A detects the collision and it will abort the message or the frame here. Okay. Now this CSMA-CD, that is with the collision detection, to work we need to restrict the frame size at this point to avoid collision. Okay. So before sending the last frame bit of each frame, it should detect collision if any and abort it, isn't it? So therefore this TFR, that is transmission average frame transmission time, should be at least 2 times the maximum propagation time, that is TP. Okay, that is your TFR, that is the average frame transmission time. TFR should be at least 2 times 2 into TP, that is propagation time, maximum propagation time, TP. Okay. Now to understand this, we'll see to this example here, simple example given. Okay. A network using CSMA CD has a bandwidth of 10 Mbps. This is the bandwidth, the 10 megabits per second. If the maximum propagation time, that is TP, okay, including the delays in the devices and ignoring the time needed to send a jamming signal, is 25.6 microseconds. Okay, that is your TP is 25.6 microseconds. What is the minimum size of the frame? We have to find the minimum size of the frame in order to detect the collision. If you know the minimum size of the frame, then you can easily detect the collision. That is what you are doing in this particular protocol, isn't it? CSMA CD with the collision detection. Now the frame transmission time is TFR is equal to 2 times of TP. TP is already given here, maximum propagation time. So 25.6 microsecond into 2, that is 51.2 microseconds. This means in the worst case, a station needs to transmit for a period of this much microseconds, that is 51.2 microseconds to detect the collision. Okay, now it has to transmit for this long, then what should be the minimum frame size? The minimum size of the frame is, how to find the size of the frame? Earlier class we had a formula, minimum frame size is equal to bandwidth into the TFR, isn't it? Let us see, frame size is equal to what? Bandwidth into, you have to note down this formula, okay, bandwidth into average frame transmission time, TFR, average frame transmission time. Okay, that is 10, here the bandwidth is 10 megabits per second, bandwidth into the time, average frame transmission time, that is 51.2 microseconds is equal to 512 bits. That is your frame size, 512 bits, or you can say divided by 8, right? That is 64 bytes is your frame size. Total frame size should be 64 bytes, then only you can detect the collision. Next is the flow diagram for the CSMA, carrier sense multiple access with collision detection. Okay. Now it starts from here. Okay. Station has a frame to send. Now initially the K represents the number of attempts. Initially it is 0. This is the first attempt. So the initial attempt is 0, 0. Now at this point apply any one of the persistence methods, either of the three here, one persistent, non-persistent, p-persistent. Okay. And when you apply this, if it will find the channel as idle. Okay. It will now, when the channel is idle, it is eligible for transmission, right? At this point you are checking if a transmission done or collision detected. Okay. If no, that is collision is not detected, then transmit and receive. The frame will transmit and receive. Or else if the collision has been detected, there is a collision, then if collision detected, no, then success, that is you can transmit the frame. If yes, there is a collision, then send a jamming signal. Jamming signal, I told you, when the station, in our example, when station C detects the collision first, it will send a signal to the neighboring nodes or stations. That is the jamming signal. That is to abort all the packets. Okay. Now, at next it will increment the number of attempts. Here k is equal to k plus 1. Here you are checking if the number of attempts is more than the maximum number of attempts. Normally it is 15. Last class I told you number of attempts maximum. Usually it is 15. Okay. Next, what happens if it is more than the number of maximum attempts, then this attempt needs to be aborted. This packet or frame needs to be aborted. Okay, stop. Else choose a random number r between 0 and 2 raised to k minus 1, and then wait for a back of time TB. TB is given by either random number into the propagation time or the random number into the average frame transmission time. Okay. And then again apply the persistence methods and go through. Again looping will happen here. Next is the energy level during transmission. Idleness or collision. See, on a wired network, energy level is almost double during a collision. This is how a receiver tells if there is a collision in case of wired network. Okay, but on wireless network, the energy level is not that high. Barely it will take 5 to 10% higher. So with the wireless, we need to avoid the collisions, right? Okay, there are three energy level during transmission. That is, one is 0, next one is normal, and one more is abnormal. 0 means that means the channel is idle. If the energy level is 0, that means the channel is idle. Okay, at this point, see here, idle. Okay, next, normal means usually it says that the channel is busy. That is, the frame transmission is taking place. Okay. Abnormal means there is collision. See, this shows the abnormal energy level. That is, it indicates that there is collision. Next, we'll see to the next protocol, that is carrier sense multiple access with collision avoidance. Usually this protocol we use it for wireless networks. Collisions are avoided using these three strategies. Before that, what is this CSMSCA? Carrier sense multiple access with collision avoidance was invented for wireless networks. Collisions are avoided through the use of CSMSCA's three strategies. That is, first one is the interframe space. Second one is the contention window, and the third one is the acknowledgements. Okay, now what is this interframe space? We'll see. Collisions are avoided by differing transmission even if the channel is found idle. Okay, when an idle channel is found, the station does not send immediately. It waits for a period of time called the interframe space. See, in the second one, that is in the non-persistence, you saw that first the station will go on checking if the channel is idle or not, isn't it? Continuously it will sense. Once in the non-persistence, actually, once if it sees that the channel is idle, in that case it will wait for a time period. Okay, same here, this will wait for a time period. This time period for which it waits, that is called the interframe space. See to this diagram, you will understand what is interframe space. See, the station is continuously sensing here. Okay, and then after sensing at some point, it will see that the channel is idle. This is not busy, it is idle. At this point, it will not send the frame directly in this point. Instead, it will wait for a time period called this interframe space. This is called the interframe space. This is why it is waiting is because between these time interval, if there is any collisions, after this time interval, the channel will become busy here. That's why. Okay. Now, one more strategy for this CSMSEA is using the contention window, second strategy. Okay, this figure is to show the contention window here. See, in this, it is an amount of time divided into slots as shown here. This contention window is the amount of time. This is the time period divided into n number of slots. Okay. Now, these slots are according to the binary exponential. Now, when a station which wants to send will choose a random slot out of this, any one of the slot out of it as its wait time. Then if it cannot find its idle channel, then it doubles each time the station cannot detect an idle channel after this interframe space. Understood? After this, a station will choose one slot, isn't it? Again, in that particular slot, if it is busy, channel is busy, then it will double the time. Okay, again it will choose the double time of this one, this slot period, and again it will sense the channel. Okay, here the important change is that the station needs to sense the channel after each time slot, and if the station finds the channel busy, it will not restart the process. That is, even if till here, after checking till here also, even if the channel is busy, it will not restart the process. Instead, it will just stop the timer and restarts it when the channel is sensed as idle. Okay. This gives priority to the station with the longest waiting time. Because of this continuously sensing, then IFS, then this contention window. Because of this, it will give the longest waiting time. And the last strategy, that is the acknowledgement, sending the acknowledgement. That is we use a positive acknowledgement and a timeout timer in this CSMA with collision avoidance to guarantee that the receiver has received the frame. Okay, this shows the flow diagram of CSMA CA, that is carrier sense multiple access with collision avoidance. Okay, here it starts at this time. Station has a frame to send. Okay, so the number of attempts initially is k is equal to 0, right? Okay, next what it will do, it will check if the channel is free, that is carrier sense. It is checking if carriers are present in the channel or not. And then what it will do, if it is false, again and again it will check the initial step it is. That is, see here, this one continuously sends. Okay, next once if it is true, that is the channel is idle, then it will wait for interframe space, and then next is the contention window here. Okay, next one, that is, choose a random number r between 0 and 2 raised to k minus 1 and use the rth slot, whichever slot you get, you are using that particular slot. Then send a RTS, that is request to send. This is sent from the sender to the receiver, the request to send. Okay, next it will set a timer and then check if the CTS received before the timeout. CTS is nothing but clear to send. This CTS message is sent from the receiver to the sender to say that yes, I am ready to receive the data. Understood? That is why you use CTS message. Okay. Now, once if it receives the CTS, yes, true, then it will wait for another interframe space time, and then it will send the frame, that is called transmission. Okay, transmission will take place, and then next what it will do, it will set a timer here, and before the timer expires, if it gets the acknowledgement, then the transmission is successful. Else what happens if it is false, that is the sender has not received a acknowledgement from the receiver, then in that case what happens, it will increase the number of attempts, k is equal to k plus 1, and then again it will check the limit whether k has crossed the limit. Usually it is 15, isn't it? 15 attempts to check the channel is free or not, the number of attempts it is in. Okay, if it is more than the maximum limit, then it has to be aborted. Okay, else it has to wait for TB seconds, that is the back of time. Usually TB is given by what, how much, r into either maximum propagation time or r into the average frame transmission time. Okay, and then back to this one, that is persistence procedures. Check if the channel is idle or not. Okay, next is the frame exchange time limit, timeline, frame exchange timeline. Okay, this figure shows the exchange of data and control frames in time. Before sending a frame, the source station here senses the medium by checking the energy level at the carrier frequency. Energy level means we already discussed the 3 energy levels, isn't it? That is, first one is 0, normal, abnormal. 0 means idle. Normal means a transmission is taking place, and abnormal means there is a collision. Now, when it sees that it is idle, the first one, that is 0. Okay, energy level is 0. The station needs to wait for a time period here. See, waiting for a time period, that is called DIFS time period. It is nothing but DCF, interframe space time. Okay, this DCF is nothing but distributed coordination function. DCF, interframe space time. This DCF, it is a protocol specified by the IEEE. Okay, else you can say it as distributed interframe space also. Okay, now it will wait for DIFS time period, and then it will send a RTS frame to the destination B. RTS is nothing but request to send. It is sending a request to B here, that is the destination. Now what the destination B will do, it will wait for a time period called SIFS, that is the short interframe space. Short interframe space. Okay, it will wait for this SIFS time period, and then it will send a CTS frame, that is clear to send. That means destination B is telling source A that I am ready to receive the data. Okay, now here the source, what it will do, again it will wait for a short interframe space, this one, short interframe space, and then it will send its data to the destination B. Okay, whatever data this has to send to B, it will send all the data, and then it will wait for a short interframe space again, and then it will send the acknowledgement to the source A. That is, acknowledgement is nothing but to understand, say that I have finished reading all the data. That is, I have received the data. It will acknowledge it to the sender, that is the source. Now, what about the other stations when this A and B are transmitting? What happens here? Here is the concept called NAV, that is a network allocation vector. We say it as network allocation vector. When a station sends RTS frame, it includes the duration of time that it needs to occupy the channel. This duration it will include in this RTS frame. Okay. Those stations affected by this transmission, that is the transmission between A and B, these stations which is affected by this transmission will create a timer now. That is, it will set a timer called this NAV, that is a network allocation vector timer, which is the time which is present in the RTS, isn't it? That is which shows how much time must pass before these stations are allowed to check the channel for idleness. Okay, every time when a station accesses the channel and sends RTS, any station, okay, other stations will start the timer and wait until the timer gets over to check the channel for idleness. Okay, it will check for this duration, and then only it will start checking for the channel idleness. This is called NAV time. The next one we will see in the next video, next topic.